Hello, students. Today we are doing lesson 10 from Unit 2. And in this lesson, we're going to be starting to graph. So, the very first thing I would like for you to try to plot these points. This is review. So, take a minute to try to plot these points on this coordinate grid. All right. So, this is something that you have done in the past. And when you're asked to plot points, this is a coordinate grid, okay? And when I look at, I'm going to skip A for just one moment, and we're going to look at B first. We're actually going to plot B first. If we want to plot a point like 1, 8, what we need to remember is that these two lines have special names. Okay, this is called, the bottom line here going across is called the x-axis, and this line going up and down is called the y-axis. And when we have a point, each number represents where to go on either the x or the y-axis. So in this case, when x is equal to 1, y is equal to 8. And so the way we would plot this is we're going to go to 1 on the x-axis. So I know I'm going to be looking at the 1, and I know that we're looking at 8 on the y. Okay, so I'm going to put a little dot here. And I know that the point then, 1, 8, or the coordinate, that's what else we would call these, is going to be where 8 and 1 meet. So I know if I were to kind of, whoa, that's not a very good line, but if I were to trace these lines until those two meet, I'm going to end up with the point of 1, 8. So this is 1, 8. Okay. The other thing, another little quick tool that you might consider is I've had students in the past use this tool to remember that when you're plotting points and you look at the coordinates, you're going to step right up, kind of like if you're at a carnival or something and somebody might say, step right up and try to win this prize, right? So the reason why this is a helpful tool, because you might be going, okay, whatever, how does this connect to math, is step right up tells us that since right comes first in our saying, step right up, that means the first coordinate is going to tell you which way to go, left and right. And the second coordinate is, or the second part of our tool here, up, tells you whether you go up or down. So the x comes first, so that means you're going to go right or left first, and the y coordinate is second, and it tells you where to go up and down. So if you continue to plot these points, C is 2, 6. I'll go ahead and, whoops, I guess I need to go back to my arrow here. 6 is 2, 6. So we go to 2 on our x, because x is first, 6 on our y, and they meet here. So here's 2, 6. For 3, it's 3 on our x, up to 4. So we're stepping right first and then going up. And then here we go to 4, 2. Okay. And now the last thing that we're left with is A. Point A is a little different because it's got a 0, doesn't it? So when we see 0, 10, it follows the same suit. We're going to step right up. So the first one is 0. So on my right, my left to right, we're going to go 0. So here's the 0 on the x-axis, right? And now we're going to go up to 10. So this is point A, which is 0, 10. Okay? And the last thing that you're going to need to know is, what is this point called? So this point is called, well, if we were to write it out, it's right? 0.00. And it has a special name. 0, is where we start on the coordinate grid, right? And it's actually called, and you're going to need to know this name, origin. And the reason it's called the origin is I can actually make a connection to your social studies that you've learned. Origin stories in social studies, you might hear, or comic books, for so to speak, like Superman. If I were to ask, well, what's Superman's origin story? You're going to tell me that Superman was on his planet, and on his planet, I think it's Krypton, it was being destroyed. So his parents sent him away and he landed on Earth. And that is how Superman got to Earth and kind of became who he was, right? So that was like how he started out. So when we talk about the origin in math being 0, we're talking about how 0 is kind of the start of our grid. This is where the X and Y both start right here. Okay? And like I said, you're just going to need to really remember that for the future. So don't forget that word. And today, like I said, we're doing lesson 10. In lesson 10, we're starting graphing. And we are going to be looking at graphing and proportional relationships. So the first activity we're going to be doing is called T-shirts for sale. And in this, I want to buy T-shirts for the volleyball team. And I was able to find a deal where you could get 8 shirts for $64. So right now I want you to go ahead, fill in the table, and then write an equation for this table. So you can pause and do that. Okay, so here's what I've done. I went ahead and filled in the table. And to do that, I knew I had to look at this and decide, how did I get from 8 shirts costing $64? So I knew if I had a bar model with 8 shirts, so if I divided this up into 8 separate pieces, one for each t-shirt, I knew that all 8 shirts cost $64. And the very first question says, well, how much does just one shirt cost? So I knew that to do that, I'm going to have to take that $64 and divide it equally into these 8 t-shirts, right? So 64 divided by 8, let me know that, oh, I take 8 and I multiply it by $8 because every shirt costs $8. And you can see how I found that. Then I was simply able to use that for the rest, right? If one shirt is $8, 2 shirts is $16. And then for this one, it was a little different because we had $24. We knew that, well, how many shirts would cost $24? Well, 8, that's 16. Oh, look, 3 8s, 3 shirts costs $24. So the last task was write an equation. I know this is proportional because it has a constant of proportionality, right? We're multiplying all of X by the same thing. So when we divide Y divided by X, we always get 8. So it's a constant proportionality. And I can use this idea here to help write my equation. So I know that this column, Y, will equal the constant of proportionality, which is K, times X. And in this case, the X is standing for the number of shirts. So this is an equation for the table. All right, so now let's use this. Okay, so now I'm asking you, here's the table. Okay, we have to plot the points, and then we have to answer some questions using that. So I want you to go ahead and do that, and we'll come back to this. Okay, so I started by plotting just this first point. So I knew when X is 1, Y is 8. So I started in my origin, I went to 1 because this is my x-axis. This is my y-axis. So I go over to 1, and then I knew I had to go up to 8. And to do this, I had to figure out, well, if from here to here is 10, I had to figure out what are each one of these lines worth, right? So I'm seeing 10s being divided into 1, 2, 3, 4, 5 slices. So that tells me each one of these is 2, 4, 6, 8. Each one's 2, right? You could use division to figure that out. Some people just guess, like I guessed. I looked at that and went, okay, let's try 2s first. And I did 2s. I knew 1s wasn't it. And then I tried, okay, if the 2s didn't work, maybe you try 5s, right? So here's 1/8. Next on my table is 2/16. So I would go to 2. And now I have to go up 16. So there's 10, 12, 14, 16. Here's my next one. Then my next value here is when x is 3, y is 24. So I'm going to start my origin, go to 3, and go up to 24. So there's 20, 22, 24. Okay. And I'm going to do that for each one. 4. So I go over 4, up 32. There's 30. There's 32. 540. Okay. 5 up 40. Ooh, that's easy. It's on the line. 648. So I'd see there's 40, 42, 46. Wait, I think I messed up. 42, 44, 46, 48. There we go. Okay. And so now you can kind of notice we've got the points. What are you noticing about the graph? I noticed that they all kind of line up. They're going in a diagonal line. And I could even I'm going to draw a line and connect them. They do. They make a perfect line. That's kind of cool. Okay. So I noticed they make a diagonal line. What does the X represent? What does the Y represent? This is asking us from our scenario with the t-shirts cost $8 each. The X is telling us how many shirts are there, right? This is the number of shirts. This is how much they cost. So the X is the number of shirts, of t-shirts. The Y is the cost of the t-shirts, right? And then they want to know, is it proportional? Well, I know if I'm looking at that table every time from the last time, right, the last slide, it is proportional, right? Because we are always multiplying by 8 for each one of these. So to get from X to Y, we always do times 8. So yeah, it is proportional, isn't it? All right. So let's take a look at some other graphs and tables. We have to be able to identify what kind of tables will match up with graphs, which graphs, okay? So for this particular activity, you need to match up the tables, with a graph, okay? So I'll give you a hint and we'll get started with 1. We'll do number 1 first, and then I'll give you some time to look at these on your own. So for the first one, this one's saying when you buy 2 shirts, you get the second one at half price. So when X is 1, Y is 10. When X is 2, Y is 15. Okay, so we have to figure out which one of these is going to match with this. So I know I'm looking for the coordinates 1, 10, right? So 1, 10, right? These are parentheses. I'm looking for coordinates 2, 15, 3, 25. Okay. I personally will start out with just looking for that first one, 1, 10. So I'll just kind of go through each one and see. I'm looking for 1, 10. Ooh, that Could work, couldn't it? Let's see, what was next? 215. All right. Did we get lucky and find it on the first try? 2 and then go up 15. Well, let's see. How's this divided up? I know this is 10 from here to here, and from here is 10 to 20. So it looks like these lines are going up by 5s, right? So this is 215. All right, I want to check each one. So it goes 325, 3, there's 20, 25. Hey, how did we get so lucky? It looks like it is going to match up, right? 430, 430, then it was 540 and 645. So hey, these do match up. So I'm going to go ahead and put H and 1 together. Okay. So that's literally all you do. You're going to look at these and see, do the points match up? 0.18. So you check it out. Right? 1.8. Well, that doesn't check out, right? So see if you can match them up. All right, so let's take a look at the matches, and we'll kind of go from there. We had already matched up number 1. For number 2, the match was B. And if you take a look, we can see the point 1, and then this is 8. So that was the first one, 1, 8. Remember, so I kind of know these are going up by 5, and 8's between 5 and 10. And then it was 216. So look, it's just barely over the 15. So 216. Then it went from 4 to 32. So that matches up. The match for number 3 was G. So it started at 0.32. So 0, and then it looks to me like these are going up by 10. So let's see, 10, 20, 30, 40, 50. It is. So 0, 10, 20, 30, and it's a little bit above that. So that's a 32. And then you can check all of them, like, let's see, 20, 68. So let's see, 20, and it goes 50, 60, and it's almost to 70, but not quite. So it is 68. If you check all the rest, it's going to match up. Okay, 4 matches with D, and this one was a little different because it has some fractions in it, right? So if you take a look, the first one was 1 and 1/3. And if we look at our chart, here's one whole, and it's actually being divided into 3 equal parts. So this would be 1/3, 1 out of 3 to make one whole. So 1, 1/3. For number 2, it was 2 and 2/3. For 3 cups of rice, it's 1 whole cup, so 3, 1, right? And if we continue, you're going to see a pattern there. And finally, for card 5, it matched with card A. All right, so here we go. Here's our A. All right, so these are our matches. Let's try another set. These are maybe going to be a little different because there are some decimals. So remember what decimals mean. Go ahead and we're going to try to match the tables to the graphs. Okay, so maybe if you're having trouble, here's something to consider. I went ahead and just put these in order just because I like things in order. I'm a math teacher. So I did 6, 7, 8, 9, and 10. And I went ahead and started here. Actually this time, maybe we'll start with the graphs. So I happen to, let's pick up F and look at F's graph. And I'm going to kind of look at this very first point, maybe, and see what it's at, right? So I'm looking at it, and it looks like the X value is 2, so it goes over to 2. We're looking at this point here. It's 2, and then something that's between 5 and 10, but closer to 10. Maybe like an 8 or a 9. So I'm going to go ahead and just start and look, is there one of these that goes 2 and then maybe 8 or 9? It's not this because 2 matches up with 4. So it's not that. Okay, this one has 2, 8. 2, 3.2. That's definitely not it. This one doesn't even have a 2 on it, so it can't be that. And this one has 2, 4. Ooh, so it looks like it might be this one. So I'll just do a couple other quick checks. Let's see, 6, 24. Let's see if that's on there. 6, and then up, There's 20. Ooh, good, because that's 25 and that's just less. Ooh, so I think F matches. Okay, let's take a look at this one. This one, I don't know. We could pick any point really. Let's see here. Ooh, gosh. Ooh, yuck. Decimals, right? No problem. Let's look and see. First of all, let's figure out what these lines are going up by, right? So this is 2/10, that's 4/10, 6/10, right? Okay, I think I see a pattern. I think they're going up by 1/10. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7, 8, 9. 1 whole is 10/10. All right, cool. So I know that each one of these is going up by 0.1 or 1/10, right? And if you're having trouble with that, because that can be a little tricky, just think of a number line. Ooh, it's not really a line, is it? So we're looking like here. I pick out 1 whole, 0 and 1, right? So I know it's 0 and 1. I always pick a whole. That's usually helpful. And then I look and see how many parts did it get broken into. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. So that helps me know that, oh, okay, cool. There's 10 equal parts. And it was alternating, right? So if that's 0.2, 0.4, 0.6, 0.8, and then 1 whole, right? So that helps me maybe visualize it. It's another way to do it, right? And then I know, oh, well, this has to be 0.1, 0.3, and so on. So each one's going up by 1/10. So now that I got that figured out, I can go back to this and see the first number should be 10, and then it looks like it's between 1/10 and 2/10. Okay, so let's see, 1/10 and 2/10. It starts with 10. Well, all right, so 10 is not even on here. 10, okay, that's a whole number of 40, not it. Oh yeah, plus we already matched it. No 10 here. Okay, there's a 10 here and a 10 here. Oh, well now it's easy. 10.015, that's a decimal and this is 100. That clearly does not go with what we're on. It's got to be this. Was it this one? 10, yep. And 0.15. Oh, that makes sense. Okay, so we know this one matches here. Okay. All right, and okay, let's look at this guy. This one goes 1 and then less than 2 for the y, right? 1 and then less than 2 over here. So, okay, 1, 2. Well, it was less than 2. Can't be that. This one says 1 and 1.6. Ooh, 1.6 is close to 2. I'm going to keep that in mind. And this one says 1, 1. So that can't be it. All right, cool. It's got to be here, right? Double check 1. 4 and then a little bit between 6 and 7. 4. Ooh, good. It's between 6 and 7, right? 4, 6.4. So that means we're down to 2. All right. Ooh, 1 has 0.12 and 1 has 0.11. Ooh, this should be easy. Let's look at this. Okay. So this one has 0.12. So it must go with this. And let's double check. Does it start with 1, 1? Ooh, gosh, it's hard to tell. Could be. It looks like it. The second one was 2, 4. So 2. Okay, this is 5, 4. Okay, this is it. So now we've got these matches. All right, now we have to go back to the sorts, and what we're going to do, this is a very timely process, right? We're going to sort the sorts, and we're going to put the ones that are proportional on the left of the screen and one that are not proportional on the right, okay? So I'm going to go back to the first sort we did, and I do have to identify whether they're proportional or not, and I can use the table, right? So remember, if we can multiply all of these by the same number, the x's by the same number to get y, meaning we can find a COP, then it's proportional. If not, then it's not. So we've been using the technique of doing y divided by x for each row. I'm going to show you a different technique just in case you don't like to do it that way. All right. And I do find this one easier. So hopefully maybe you will too. For the first problem, if I want to know if this table is proportional, I personally know I have to do 1 times 10 to get 10, right? Then I try it out on the second one. What's 2 times 10? 2 times 10 is 20. I did not get 20. I got 15. So that means I am not multiplying 2 by 10 to get 15, right? And like 3 times 10 is 30. Well, this is saying y is 25. So this isn't proportional because I'm not going to multiply by the same number, right? So because I can't do 2 times 10 and get 15, this whole thing is not proportional. So what did it say? To put this on the right side. Shoot, I am going to erase this because it'll get moved when I move it. All right, so let me, that's not what I wanted. Let's move this whole thing down a little, whole thing down so that we can look at them one at a time. Okay, so this is not proportional. I'm going to put it on the right side. Let's look at this one. Okay, again, we can do the same thing. We're going to see, are we multiplying the x by the same number to get the y? So I know, well, 1 times 8 is 8. So now I'm going to try that out. Is 2 times 8? Ooh, it's 16. All right, is 4 times 8? Yes, it's 32. So I can see this is working out. For each one, we multiply by 8. So this is proportional. So let's move this to our proportional side. Oh, that moved with it. Cool. All right, so let's look at this one. Okay, so I know, well, first of all, I know nothing times, anytime I multiply by 0, I get 0. So, okay, well, you can't even do that problem. So now, what do I multiply 10 by to get 50? 5. 10 times 5 is 50. Okay, so let's try 20 times 5. I know is 100. That equals 100, not 68. So that means because I can't multiply 20 by 5 to get 68, this is not proportional. I can move it all over. Let's get this puppy over here. That was easy. All right, let's look at this one. 1 times what is 1/3? Well, 1 times 1/3 is 1/3. Okay. 2 times 1/3. Let's see what we get. 2 times 1/3 is 2/3. Ooh, okay. 3 times 1/3 is 3. All right. It's not 3. 3 times 1/3 is 1. And I did get 1. Cool. Looks like this is working out. 4 times 1/3 is 1 1/3. And you can put these in the calculator to check this out. 5 times 1/3, also 1 2/3. Cool. And 6 times 1/3 is in fact 2. So this is proportional. We're going to move it to the left. And the last one, okay. 1, so we're going to see what times x gives us y. So I know this is times 8, right? So 1 times 8 is 8. So let's try 2 times 8. 2 times 8 is not, we would do this, not 10, right? 2 times 8 is 16. So I already know I don't have to go any further. Not proportional. Okay? Now, here's what I'm going to do. The whole purpose of this, whoops, I want to put these graphs at the bottom. Come on, go with it. The whole purpose of this is because we can look at a graph and actually see if it's proportional or not. So we're going to try to see if we notice any patterns. So start looking at these and seeing what is it that you're noticing about them. Do the proportional ones have anything in common? I'll even draw a line. We know that these are proportional, these are not. Do the ones that are not proportional have anything in common, or are they different from these? Think about that. We're going to go to the next one. So do the same thing for this that we did on the other one. We're going to put proportional on the left and non-proportional on the right. Okay, so just to speed things along, what I found were that these three do have constants of proportionality. I went through, I didn't write this on this one, but yes, you multiply all of the x's by 15 thousandths to get your y. Over here, the constant of proportionality is 4, and over here it was 1.6. Card 2 was a little tricky because maybe you thought it was working out because 1 times 2 is 2, 2 times 2 is 4. So we're thinking, oh, we got a pattern. Nope, because 3 times 2 is not 7, it's 6. So that means this is not proportional. And then this one is not proportional because 1 times 1 is 1. When you do the times 1 to the 2, you don't get 4, you get 2. So it's not proportional. So now we have an even better picture of what's happening with our graphs. Okay. When I'm looking at the graphs, I'm noticing here's the 3 that are proportional. Here's the 3 that are proportional. So I'm looking at those graphs. Here's ones that are not. Okay. I'm going to go back to this one, and I'm going to remind myself, these are proportional here, and these are not. Okay, so here are some things that you might be noticing. If I could draw a straight line, you're going to notice if I draw a straight line through the proportional ones, so there's those 2, it's a straight line, isn't it? And if I draw, okay, so that's proportional, right? If I connect these lines, and notice I am going beyond them, but if I connect the dots, I should say, this is a straight line too, but it's not proportional. This one's straight. It's not proportional though, and this one is, it's kind of straight. It's pretty straight. Maybe if I, okay. So these 3 are proportional or not proportional. They're all straight lines. So what's the difference then between these and these? Hopefully you said the ones that are proportional, they are straight lines and they start at the origin. Okay, so start at the origin. That's important. These, even though they are straight lines, which we call these linear, by the way. All right, linear means straight. You're going to need to know that in 8th grade a lot. So these linear, these straight lines start at the origin and they're straight, they're linear. This one, non-linear, or it is straight, it's linear, but it does not start at the origin. This does not start at the origin. It does not start down here. This one's super close to starting at the origin, but it doesn't. Okay, if we were to really get a straight edge in there, it's going to start just above the origin. All right, so all proportional graphs are linear, meaning they're straight lines, and they start at the origin. Origin meaning 0.00. Okay, remember how I said we need to remember that. So let's look here at the second grouping. Okay, so now looking at these last tables, I'm actually going to increase these so we can actually see these a little bit better. And we're going to look at just the graphs to decide if they are in fact proportional or not. So when we look at this, what we want to do is kind of connect our dot by dot. Okay, so far it's looking pretty linear, isn't it? And it is indeed, if we look at the graph, we already know that this is a proportional table. And when we look at the graph, it does start in the origin. That's our first check. And it is linear. It is straight. So therefore, it's proportional graph. All right. Let's look at this guy. So we do know that the table is proportional, and let's check to make sure that the graph matches up with what we know about graphs that are proportional. So I'm trying to connect it dot by dot. And well, there you go. It starts at the origin and is linear. It is a straight line. Okay. Let's check this guy out. This is also proportional based on our table. So I'm going to connect the dots the best I can. And it's pretty, yeah, it does go through the origin. It is easier when we have line tools and when we use straight edges with paper and pencil. So it starts in the origin and it's linear. It goes in a straight line. Whoops. Okay. Now let's take a look at this guy. We do know that this was not proportional based on the table. So let's look at the graph and see. So I'm going to go from dot to dot. I've already messed up. Okay. All right. So when I'm connecting this, it's hard to tell, but this is not linear. When I went from here to here, it's like as you connect them, you can almost feel whether they're supposed to be in a straight line or not, right? So like there's certain parts of it that is curvy, and it also doesn't appear to start at the origin. So this, not proportional. It doesn't start at the origin and it's not linear. Oops. And finally, our last one, we're going to check it out. Whoa, I can already tell. Can you already tell? This is, it's curvy. Gosh, and it does not start at the origin. All right, so it's not linear and it does not start at the origin. So this, not proportional. Okay. So we have already done this. So we know proportional relationships, they will make a straight line. We are also using the word linear. Linear means straight line, okay? So it must make a straight line and it must travel through the origin, which is 0.00, in order to be a proportional relationship, the graph, okay? So literally you can look at graphs now and decide if something's proportional or not, okay? So if you were to explain to your friend who missed class what they missed, think about what you might tell them if they wanted to know how they could look at a graph and tell if it's proportional or not. So take a minute to put that in. So you can hit pause. All right. So I would tell my friend that the line must be linear, meaning it must make a straight line, And it must go through the origin, which is 0.00. Okay, so hopefully you were able to understand our learning targets. So can we tell whether a relationship is proportional by looking at its graph? You might fall into any one of these categories.